In today's video, we're going to look at section 2-6, ratios and proportions. So the first thing we need to look at is, what is a ratio? A ratio is a comparison of two numbers. So anytime you compare two numbers, you're creating a ratio. So common forms are x to y, x colon y, and x over y. In math, we typically see it as a fraction of x over y. Now, a proportion is an equation stating that two ratios are equal. So using an equal sign to show two ratios are the same, even though they might look different. Okay, so we want to know, determine whether the ratios 4 over 5 and 24 over 30 form a proportion. So as we write these down, we got to know, are they equal? So on the right, on the left one, 4/5, there's nothing I can do. That's simplified. But 24 over 30, I can reduce both by dividing by 6. So I'm going to divide by 6 here. I get a 4, and divide 6 here, and I get a 5. So the right one actually is 4/5, meaning they are actually equal. So this is a proportion. Okay, these two ratios are proportion. So an easier way to do this, in case there are numbers that are harder to work with, we have what we call the means extremes product property. And what we do here is, if A over B is equal to C over D, then A times D is equal to B times C. So what they're saying is A times D, right here, is equal to B times C. So it's what we call cross multiply. Okay, cross multiply across the equal sign. So we want to use that to determine whether we have a proportion. So 0.4 over 0.8 and 0.7 over 1.4. So I'm going to do a cross multiplication here. I'm going to cross multiply here. So I get 0.4 times 1.4, and I get 0.56. And then I'm going to cross multiply here, 0.8 times 0.7, and I get 0.56. So those are equal, so yes, it is a proportion. Same thing, I'm going to cross multiply here on B. I'm going to do 6 over 8 and 24 over 28, so 6 times 28, and that is 168. And then I'm going to cross multiply 8 times 24 and get 192. Those are not equal, so no, not a proportion. And that's how we can use the cross multiplication property, or the means extremes product property. But now we look at solve the proportion. We want to know what number 4n would make this a proportion. Now we can't see exactly what n would have to be. So, like I said, we are going to cross multiply. Remember, this is stating it's equal. So, n times 16, or 16n, is equal to 15 times 24. And we get 360. Then simply solve for n. Divide by 16. So, n is equal to 22.5. So for this proportion to be true, n would have to be 22.5 or 22.5. Okay? So let's do another one. Solve each proportion. If necessary, round to the nearest hundredth. So we have r over 8 is equal to 25 over 40. So once again, cross multiply. So we get 40r is equal to 200, and we divide by 40 on both sides. Oh, I forgot to circle. This usually helps you when you circle what you're doing. So r is equal to 5. Let's do another one. 6 over 14 is equal to 7 over x minus 3. Now this one is a little bit trickier because I'm still going to cross multiply, even though there's an x minus 3 on the bottom. But here, remember, I'm taking 6 times that whole bottom. So I'm actually going to distribute. So I get 6x minus 18. I need to distribute to everything. Is equal to 7 times 14, which gives me 98. So now we're at just a little bit longer algebra problem. Add 18 to both sides. So we get 6x is equal to 116. And divide by 6 on both sides. And we get 19.3 repeating, but it says round to the nearest hundred, so we get 19.33. And there's our answer. Okay, so our process doesn't change, except we're just adding some stuff in. So now we got to look at a rate. A rate is just two measurements, a ratio having two measurements with different units of measure. So here are some examples. 1.99 per dozen eggs. So 1.99 to 12 dollars to eggs. 55 miles to 1 hour per 1 hour. $30,000 per 1 year, or to 1 year. All right. A scale compares the size of a model to the size of an actual. So you see this on a map or a globe. That makes it really easy. Some blueprints on for a building would have a scale. Okay, so Trent goes on a 30-mile bike ride every Saturday. He rides the distance in 4 hours. At this rate, how far can he ride? So it tells us he does 30 miles per, that big division bar actually means per or divide 4 hours. Now that's one of my ratios. And since I'm setting a proportion, I'm going to set it equal. And now, they're wondering, how far can he ride? So, I'm going to call this X. All right, now, on my ratio, on the 30 miles over 4 hours, I put miles on top. So, once again, I got to put miles on the top also. I have to match it up. And on the bottom, it says 6 hours. Or I put 4 hours, so I also need to put 6 hours. Okay, I'm keeping it balanced. If you put miles on top, you got to put miles on top on the second ratio. If you put hours on the top, hours would have to be on top. It doesn't matter so long as they match up. So now I'm just going to ignore the labels for now because I just need to worry about the math because everything's going to work out. So, but I still cross multiply. 30 times 6 is 180. Is equal to 4 times x, which is just 4x. Solve for x, divide by 4. So we get x, I'm just going to flip it around. X is equal to 45. And x represents miles, so it would be 45 miles. So in 6 hours, he could ride 45 miles.